All right, well, you found the quick review for Algebra 2, and this is Unit 1, Lesson 1, so we're dealing with our number system. All right, so don't forget, technically our number system is the complex numbers. The complex numbers. And the complex numbers union two things. What we normally learn, that's the real numbers, right? And so that's the left-hand side. So let me talk about the real numbers first. All right, well, what's everything that's in the real numbers? All right. So the real numbers start way inside with the natural numbers. Numbers like 1, 2, 3, 4, 5, 6, etc. counting numbers. If you add 0 to the natural numbers, you get the whole numbers. So 0, 1, 2, 3. See, any circle inside is a subset. And the natural numbers right here are a subset of the whole numbers because the n is completely in the w. So take all the natural numbers, add 0 to it, and now we're going to call it the whole numbers. So the only difference is the 0. Now when you get to the integers, there's a bit of a difference because the integers has all the negative counting numbers. -1, -2, -3, -4, etc. So watch. Add the whole numbers, add 0 and all the positives with the negatives, you get the integers. So the whole numbers is a subset of the integers. Natural numbers is a subset of the integers. Now Q is the rational numbers. So that's this box right here. And the rational numbers are anything that can be written as a fraction. So is the number 3 a rational number? Yeah, because it could be like 6/2. Isn't that 3? And that can be written as a fraction. So can a whole number, so can 0. 0 divided by 5 is a fraction. -1, -2 divided by 4. -2 divided by 1, -6 divided by 3, whatever. -6 divided by 6, whatever. Okay. The thing that gets people in trouble with rational numbers is decimal form. So if I had 0.75, I know that that can be a fraction, right? It's 3/4. So that's a rational number. All right, so you just got to be careful there with the fractions. Here it is in short because this is a quick review video. If the decimal ends, it's a rational. If the decimal repeats, it's a rational. If decimal does not repeat, non-repeat, it's irrational. And also things like pi, things like e, a lot of the roots, anything that's not in a perfect square root is an irrational number. Okay, so that's the real numbers. And then also the complex numbers involve the imaginary numbers. Those are things with I. These are square roots of negative numbers. Try as much as you can. You can't find anything times itself twice to equal -4. So this equals 4i, and it's an imaginary number. And we'll talk about those later on down the road. Okay, I also need to quickly review the properties. Hey, when you see commutative, whether you're talking addition or multiplication, you should think I can change the order. When you see the associative property, associates are those that group together, you should think I can change the grouping. When the grouping is changed, it's associative. When you see identity, you should think, hey, I need to get back to the original. A quick example of this would be something like a plus 1, a plus 0 equals a. See, I am back to the original. Okay. Next would be the inverse property. Now you're going to have two situations. You're going to add opposites to get to 0, or you're going to multiply by reciprocals to get to 1. The last thing is closure. Be careful here. Here's what closure means. That when you perform an operation, the operation leaves you a solution that's in the same set. For example, if you take integers, whenever you add integers, do you get an integer? You do. Addition is closed for integers. But here's an example that doesn't work. Is subtraction closed for natural numbers? Is subtraction closed for natural numbers? Can you take any natural number and subtract from it any other natural number and get a natural number? The answer is no. Subtraction's not closed. All right, our number system and the properties.